Okay, now that we know how to pass an object to a method, we can tackle a concept that's sometimes called a copy constructor. If you look this up online, people debate about what this means, about whether it really qualifies as one versus other languages like C++. Don't get lost in all that. Here's all you need to know. What we're doing is we're creating a constructor so that it will take some other object of the same type, so a point object, as an argument, and it will copy all the values in it. So keep this in mind when you're talking about, can I write with this? When you're talking about these objects in Java, let's say we have point P1, what that means is that memory set aside and called P1, it's not called P1, but the address of this thing will be assigned to P1. So P1 knows where it's located in memory. And it has all this stuff right here in it, including, the stuff you can't see. It's up above. It's all in here. And if you say new point again somewhere else and assign its memory address to some other point variable like P2, like we've been doing before, you've got all this stuff again, except the details, the values might be different. So the X and Y coordinates might be 0, 0, and 5 and 1, or whatever. They're two different locations in memory that are like, again, people compare classes and objects this way. It's a standard thing. The class is the blueprint. The object is the actual house. So you can use one blueprint to make 100 houses that all look the same. They have the same floor plan, and et cetera, et cetera. But they'll be at different locations on the map, right? They're not right on top of each other. And the things they have inside of them might be different furniture, different people, whatever. So kind of think of it that way. Another thing is, the cookie cutter versus the cookie. The class is the cookie cutter. The cookie is the object. This is what's going on here. We have P1 and P2. What if we want to create an instance of a class, an object, from one that already exists, so they start off with the same values, but they're still two different things? So cloning is one way to do it. And if you look up clonable and interfaces, that's kind of another way to do this in Java. It's kind of, people debate on which one's better, but I'm going to show you this way first, because you need to know it, whether you use it in the end or not. So, one way you might naively try to do this, which will not work. Let's go back to point demo. Again, I promise it's not Wuhan flu. You might say, okay, I've got point P2. I want it to be exactly the same as point P1. So I say P2 gets P1. That's a naive way to try to do this. What does this do? It might look like it works. So what I mean by that, point P1 is 4, 5, right? So if I do P2 dot print, I've still got that, either way, I've still got the static method up there, but I'm going to actually use print point. If I call that, what is it going to get? 4, 5, right? Okay, so it looks like I made a copy. That's good, right? So what if I do this? P2 dot, like in this particular copy, it's like moving through space in a game or something. So I want to change what the coordinate for Y is, because let's say it's moving downward on the screen. Usually that is a bigger number. So I want it to get B10 now. Alright, let's do that. And then let's print out and see if we actually got the changes after we changed the value of Y using the mutator, right? The setter. Looks like we did. Okay, here's the problem. P1 dot print out, print point. What happens when we print this? Oops, they're both 10 for the Y. Why? Because when you do this right here, going back, remember the strings, when you compare them, what are you comparing? You're comparing memory addresses. Here, you're assigning the memory address of P1 to P2. What does that mean? Let me draw a picture real quick. When you say new point 4, 5, this is what you're doing, and then you assign that to P1. So I'm going to put this here to symbolize that. So P1 has the address of this object. When you say P2 gets P1, what you're saying is that P2 gets the same address. So there's two variables that are pointing to the same memory. That's all you've got. So it's kind of pointless to have P1 and P2 because they both point to the same thing. What you really want is that first picture I drew that had two different rectangles, right? So the way you do that is by using a copy constructor. And there's different ways to do it, but what you want to do is make sure like you kind of manually copy all the parts. So if you're talking, the parts in this case would be the two fields, the two instance variables x and y. You want to make sure that you get the same values from the one you're copying from to the one you're copying to. So the way this would work is instead of doing P2 gets P1, let's actually leave those down there, but change this. P2 is going to get new point, and we're going to pass P1 to it as an argument. So remember, this is how you pass to a method, an object to a method, right? What's the parameter here? It's a point. We're going to call that point P inside of this method. But point is the parameter, so we need to send a point argument. What's our point? It's P1 here, right? See, the data types match. So P1 goes in there. And then, when we run this, might be kind of hard to see. You have to follow what's going on here, right? But P2, so I copy and then I print out P2 immediately. What do I see? 4 and 5, same as P1. That's what I want because I just now copied it. But then I change the Y value of P2, which should be changing the copy, right? The other place in memory, and set it to 10. Okay, so I print out P2 again, that object, and it's 10, which is what we expect. Then when I go back and print P1, the thing that we copied from, it's still 5, which is what we want. We want these two things. We want P2 to start out the same as P1, but now it's its own thing. It's its own clone, right? And it's like the other Riker from the transporter accident. He was only a chief officer because he was whatever. They had two different lives, but they started at the same point. That's the point of a copy constructor. And you might use this in lab. I think I have you create one in lab, so make sure you can come back in here and refer to it when you need to do that in the fractions lab.